This is Pre-Calc section 7.3 on the conic sections and nonlinear systems. The first part of this lesson wants you to be able to identify the four types of conic sections based on their formulas. So instead of looking at these in the order in which they were taught, let's look at easy things like parabola. Parabola is the easiest one to identify because it only has one variable squared, either x squared or y squared. Now, a subset of that is you're going to have to be able to identify if it's a vertical parabola or a horizontal parabola. If x is squared, that makes it a vertical parabola. If the y is squared, it makes it horizontal. So this is a vertical parabola, and this one is a horizontal parabola. The hyperbola is really easy to identify because it's got a minus between the squared terms. Now, it can come to you in this format, the standard form. So you have x squared over 9 minus this quantity, which tells you it's a hyperbola. Or it can be in this general form, but it still has y squared minus x squared. So when you see the minus between the squared terms, then you know it's a hyperbola. Now, in this form, when I say a minus between the squared terms, they might be separated a little bit, or they could be right next to each other. But this says 8y squared minus 4x squared. That's what makes it a hyperbola. Now, the fact that the x squared came first or is positive, then we know that this is a horizontal hyperbola. And this one, the y squared came first or is positive, is a vertical hyperbola. I told you back in section 7.2 that for us, we can look at it in terms of what came first, but some books will get tricky and show you something like this. They'll show you negative y squared over 9 plus x squared over 16 equals 1. And then you have to be careful because this really should be rewritten as x squared over 16 minus y squared over 9, which makes this a horizontal hyperbola. That's why I always write first and positive, first and positive. Now, the circle and ellipse can be a little bit similar because they both have a plus between the squared terms. The circle either has a squared equals b squared or equal squared coefficients. Now, what does that mean? Look down here. Equal squared coefficients. Those are both 4. Those are both 4. That's what tells me it is a circle. Now, what does this a squared equals b squared mean for a circle? Well, I have seen problems where we have this, we have this. And because you see a fraction there, you might think, oh, it's an ellipse. But because those two values are equal, that makes it a circle. And then the ellipse has got the plus in between, but these two numbers down here are different. Or in the general form, those two coefficients in front of x squared and y squared are different. So this next page is going to ask you to look at a bunch of formulas and decide what they are. Parabola, vertical parabola, horizontal parabola, circle, horizontal ellipse, vertical ellipse, horizontal hyperbola, or vertical hyperbola. Try to stop the video, look back at the notes on the other page, and see if you can identify what's what, and then come back to my explanation on all of these. What I look at here is the fact that only one item is squared, so I know it is some type of parabola. Not only that, because it's x squared, I know it is a vertical parabola. This has got a plus in between, so it is either a circle or an ellipse, but because these two denominators are different, it is an ellipse. Furthermore, an ellipse, you decide if it's vertical or horizontal based on the size of the denominator. Since 25 is bigger than 16, I know this is a vertical ellipse. This has got a minus in between, so I know it is some sort of hyperbola. And hyperbola, you determine horizontal or vertical based on what came first. X squared came first, it is a horizontal hyperbola. Down here we've got another plus in between, but we've got that these two are equal, which makes it a circle. Look here, you have something that's kind of in a weird form, which means we better rewrite this so that our x squared and y squared are on the same side. So x squared minus y squared equals 64. Because it's x squared minus y squared, we're looking at this idea that it is some sort of hyperbola. And as soon as you know it's a hyperbola, you know this has to be equal to 1 over here. So divide everything by 64, which will give us x squared over 64 minus y squared over 64 equals 1. So now that's in standard form. X squared came first, makes this a horizontal hyperbola. Because only the y is squared, I know it is some sort of parabola. And because it's y squared, I know it is a horizontal parabola. So I don't really need to rewrite that at all. You could move the 2 to the other side, but it really doesn't matter. This in general form, we have 2x squared plus 2y squared. Because there's a plus in between, it is either a circle or an ellipse, but because these coefficients are the same, it is a circle. 4x squared plus 16y squared. Since there's a plus in between the squared items, I know it is an ellipse. I don't know if it's a horizontal or vertical ellipse until I complete the square. So let's create some room here so I can complete the square. And what we'll have up here is 4 times parentheses, x squared minus 2x plus blank. Let's do the y squareds, plus 16 times y squared minus 6y plus blank equals the negative 4 that's already over there plus 2 more blanks. So let's complete the square. Half of 2 is 1. 1 squared is 1, but what we really added on that side is 4. Half of 6 is 3. 3 squared is 9, but what we really added is 16 times 9, which is 144. So factoring this up, this is 4 times x minus 1 squared plus 16 times y minus 3 squared equals 64. Get this equal to 1 by dividing everything by 64. Gives me x minus 1 squared over 16 plus y minus 3 squared over 4 equals 1. So now, looking at the denominators, this denominator, which is underneath x, is bigger than this denominator, so that tells me that this is a horizontal ellipse. Now there's something called eccentricity, and it's defined this way. A conic section is going to be a set of all points in a plane such that the ratio of the distance from P to a fixed point and the distance P to a fixed line is constant. The constant ratio is called the eccentricity of the conic, and it's written like this with an E. And that E is not the same as the E we had in the logarithm chapter. Now a parabola has eccentricity 1. That's the definition of a parabola. To explain that, here's a little picture over here. Here was my center, here's my focus. So we're talking about the distance to a fixed point right there. Whatever that distance is, call it D. And this distance here down to the directrix, which I'm trying to draw a straight line, that's also D. That's the definition of a parabola. That's how we formed the parabola back in 7.2. And if I do D over D, I get 1. So very simple question. If they ask you for the eccentricity of a parabola, it is 1. The circle has eccentricity 0, so those are 2 very easy answers. For an ellipse, the idea on eccentricity is the measure of its roundness. You know ellipses can be very elongated like this, or they can be almost circular, something like this. So the definition or the formula for eccentricity is C over A if you're talking about a horizontal ellipse, and C over B if it's a vertical ellipse. Now keep in mind what we've always done. A always goes with x, which is the horizontal component. B always goes with y, which is the vertical component. For the hyperbola, E equals C over A if it's a horizontal hyperbola, and C over B if it's a vertical hyperbola. Notice it's the same formula that we have for the ellipse and for the hyperbola. Both of those, because of horizontal, C over A, for vertical, C over B. But there's one other important thing about the ellipse. The ellipse's eccentricity is always between 0 and 1. The hyperbola's eccentricity is always greater than 1. That's worth memorizing. So let's take a look at 2 examples that ask us to write the equation of the conic with center at the origin and eccentricity equal to 2. So I want to do my center at the origin. I have a focus at 3, 0. Notice I'm doing like I did in 7.2. I'm going to the graph to get an idea of what I'm looking at. So I have a center of 0, 0, a focus of 3, 0, and an eccentricity of 2. 2 is greater than 1, and because 2 is greater than 1, I know it is some sort of hyperbola. That's a fact we had over here. If the eccentricity is greater than 1, that means we're talking about it being a hyperbola. We'll figure out what kind it is in a minute. So there's our center, there's our focus, And the fact that our focus and our center both lie on the horizontal axis, that tells me it is a horizontal hyperbola. If it is a horizontal hyperbola with center at the origin, it is x squared over a squared minus y squared over b squared equals 1. So all I have to figure out is a and b. Well, the fact that this is the center and this is the focus, that tells me that c is 3. So c is 3. I know that eccentricity is the formula c over either a or b. In this case, because it's a horizontal hyperbola, it's c over a. So I can use that little formula and plug in c is 3, a I don't know, but it equals an eccentricity of 2. So give this a denominator of 1, cross multiply, you have 2a equals 3, or a is 3/2. And it's okay for this to be a fraction. We didn't have many in section 7.2 where that happened, but a is 3/2. For the hyperbola, we use a squared plus b squared equals c squared. Plug in a and square it, you get 9/4 plus b squared, that's what we want to find out, equals c squared, which is 9. Subtract 9/4 from both sides, use your calculator, convert to a fraction, and we have b squared equals 27/4. Now, ordinarily, we take the square root of both sides to find b, but all we're trying to do is find the equation. We need b squared. Well, it's sitting right there. Don't do the extra work to find b. So my formula will be x squared over a squared, which is 9/4, minus y squared over 27/4 equals 1. Now, we have to clean that up arithmetically because this is a complex fraction. Remember, something over a fraction takes the bottom and flips it upside down. So this becomes 4x squared over 9 minus 4y squared over 27 equals 1. And that is the equation of the hyperbola that matches that information. One more of this type, we have center at the origin, eccentricity equals 1/2 with a vertex of 0, -8. Because the eccentricity is 1/2, that's going to tell me it is some sort of ellipse because the ellipse eccentricity is between 0 and 1. So I've got a center of 0, 0. I have a vertex at 0, -8 down here. As soon as I see that, I know that this is a vertical ellipse because the vertex and the center lie on a vertical axis. So I know for the ellipse, this will be x squared over something plus y squared over something equals 1. And the somethings are a squared and b squared. So let's see if we can find those. Because this is a vertical ellipse, this distance right here, which is 8, is my b value, because b always goes with the vertical component. So I need to find a. I can find a by using this c value. We know that e is c over b. It is c over b because this is a vertical ellipse. So c over b, c which we don't know, over 8 which we do, equals the eccentricity, which is 1/2. Cross multiply and solve. This is 2c equals 8, or c equals 4. Then we can use our a squared, b squared, and c squared to find a. Now this is an ellipse. This is a vertical ellipse. So the formula we would use is b squared minus a squared equals c squared. So that's 8 squared, which is 64, minus a squared equals c squared, which is 16. Subtract 64 from both sides gives us -a squared equals -48. I can make both of those positive. And I could square this, take the square root of this and simplify, but I don't need it. I need to know what a squared is, and I know it. It's going to go right there. So this is x squared over a squared, which is 48, plus y squared over b squared. Now I do need to square that because that is the b value, is 64, and that equals 1. The next two problems are asking us to solve these algebraically. The directions say this solves symbolically, but what they really mean is you need to use elimination or substitution to solve these. We did these before, and now we're doing them with the squared values. Very easy to use elimination on this. If you add these up, the y squareds just totally cancel out. Remember, this is a 1. 1x squared plus 2x squared is 3x squared equals 27. Divide both sides by 3. X squared is 9. Undo by taking the square root, and remember something very, very, very important, and that is your plus or minus. So the x value is plus or minus 3. I need to stuff that back into one of those equations. I'm going to choose this one because the y squared is positive. And it doesn't matter if you put a positive 3 or a negative 3 in for x because you're going to square it. So either one of those squared gives me 9 plus y squared equals 13. Subtract 9 from both sides. Y squared is 4. Again, we're going to take the square root of both sides, and I have plus or minus 2. Now, what MathLab is expecting you to do now is pair these up in ordered pair form. So if I take positive 3, pair it with positive 2. That's one of my points of intersection. Take positive 3, pair it with negative 2. That's another point of intersection. Do the same thing with negative 3. Pair it with positive 2, and then take negative 3, pair it with negative 2. And those are my 4 points of intersection, and MathLab will tell you to enter those like that, separated by a comma. The last one was pretty easy to just add them together and they canceled out. This one we need to do a little bit of multiplying, and what I notice is that for the y's, they are already opposite signs. So I choose to multiply this by 5 and multiply this by 4. So I have 15x squared plus 20y squared equals 315. Multiply through by 4 is 16x squared minus 20y squared equals negative 36. Now when I add, the y squareds cancel. I have 31x squared equals 279. Divide by 31, and x squared is 9. Undo by taking the square root. So x is plus or minus 3. Remember the plus or minus. Anytime you solve by taking the square root, you need a plus or minus. I need to plug that back into either one of these equations. I choose to go to the top one because that's a positive y squared, and I won't have to mess with a sign. So this is 3 times 3 squared, which is 9, plus 4y squared equals 63. 3 times 9 is 27. Subtract 27 from both sides gives me 4y squared is 36. Divide both sides by 4, and I have y squared equals 9. Take the square root. Don't forget your plus or minus. So x is plus or minus 3. Y is plus or minus 3. Pair these up. This will be 3 with a positive 3. 3 with a negative 3. Negative 3 with a positive 3. And negative 3 with a negative 3. And it doesn't matter what order you would put these points in. You could type negative 3 comma negative 3 in first, and MathLab won't care.